Hello, this is Mr. Wynn, and this video is Basic Probability Part 1. Probability is a mathematical way to describe how likely something is going to occur. It can range from 0, which is impossible, to 1, which is certain. It can be written as a fraction, decimal, or percent. For example, a probability of 1/2 can be written as 0.5 or 50%. 2/5 can be written as 0.4 or 40%. 1/8 or 1 out of 8 can also be written as 0.125 or 12.5%. 3 out of 100 can be 0.03 or 3%. Also note 0 means 0%, 1 means 100%. Some vocabulary. An experiment is a situation that involves chance and leads to results. An example would be flipping a coin. An outcome is the result of a single trial or performance of an experiment. In the example above, the possible outcomes could be a heads or a tails. An event is one or more outcomes of an experiment. In the example above, one event would be just getting a tails. Equally likely means all events have the same likelihood of occurring. And random means occurring without any definite reason, pattern, method, purpose, or aim. It's basically unpredictable. A little more vocabulary. A sample space of an experiment is a set of all possible outcomes. It can be organized in a list, table, or tree diagram. So the official probability event is a fraction. It's the number of outcomes that make the event true over the total number of outcomes that are equally likely to occur. I usually just use a short idea where probably is the wanted options or the total options, or I like saying W over T. What we want over the total. So, for example, a fair coin is flipped 3 times. Create a tree diagram to show the sample space, then answer the questions below. So if you toss a coin, you either get heads or tails. So we could get heads or tails. Then we're going to toss again. We could again get a heads or tails. So here's an outcome, heads heads, or heads tails, or maybe tails heads, tails tails. And then we do a third time. Again, heads, tails, depending on which one it is. So our sample space is going to be these. We could have got heads 3 times in a row, heads, 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 or you got heads 2 times in a row, then a tails, or heads, then tails and heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So there's 8 different possibilities here. So what is the probability of getting no heads? So here's 1, 2, 3, 4, 5, 6, 7, 8, 8 total possibilities. Where there's no heads, this has 3 heads, this has 2, 2, 1, 2, 1, 1, 0. So this is the only one that has no heads. So we have 1 out of all 8 chances to get no heads. What's probably going to have at least 1 head? So this means you either got 1 head, 2 heads, or even 3 heads. So this counts because it's 2 heads. This counts 2 heads. This counts 1 head. This counts 2 heads. Counts 1 head. Counts 1 head. This does not count 0. So 7 of these count. So 7 things we want over the 8 total possibilities. So that's basic probability when flipping a coin 3 times. Now we have the fundamental counting principle. That is a way to find out the total number of possible outcomes without needing to list the entire sample space, especially if it's going to be too big. All you need to do is multiply the number of possible outcomes from each stage or event. So for example, looking at the last problem, how many different possible ways are there to flip a fair coin 3 times? From this last picture, we know there's 8 total ways that are different. So our first flip had 2 options, either heads or tails. Then we multiply the second flip, has 2 options, heads or tails. Third flip had 2 options, heads or tails. So 2 times 2 times 2 would be 8. There's 8 different possibilities. So here's a much bigger one. How many different possible outfits can you make? You have 3 shirts, 4 shorts, 5 socks, and 2 shoes to choose from. Now I tried to draw out the whole sample space, and I could minimize these, but it took a while. You have the first shirt with the first short, with the first sock with the first shoe, or first shirt, first short, second sock, second shoe. But all of these are possibilities. So instead of listing it out because it takes all your space, probably takes more than 1 piece of paper, you just multiply. Our first choice, we have 3 things. Our second option, we have 4 things. Third option, we have 5 things. Last option, we have 2 things. We multiply all those together. 3 times 4 is 12, times 5 is 60, times 2 is 120. There's 120 different possible outfits. Now, if you really count this, there are 10 here, then 10 here, 10 here, 10 here. So there's 40 different possibilities with the shirt 1, 40 more with shirt 2, 40 more with shirt 3. So 40 plus 40 plus 40 is 120. So that is the correct number. All right. And lastly, the probability of complements rule simply states that the probability of an event not happening is equal to 1 minus the probability that it will happen. So it's pretty common sense. For example, if something has a 60% chance of happening, then it has a 40% chance of not happening. Here's the math. 1, or I guess in decimal form, 1 minus 0.60, because that's 6%, is 0.40, so you know that's 40%. So in percentage form, 100% minus 60% gives you 40%. Alright, so that's not too exciting, but here's a cooler application. A more exciting application of this rule can come from the first problem in the video. Flip a coin 3 times and state the probability of getting at least 1 heads. Now earlier I had to count the number of things that had 1 heads, the number of things that had 2 heads, the number of things that had 3 heads, right? But sometimes it's simpler or easier to count the things that have no heads and subtract it from 1. So we know that there's 8 possibilities, because 2 times 2 times 2. Now how many different possibilities have no heads? Well, only one has no heads. It was the triple tails. So if we do 1 minus that triple tails option, 1 out of 8, gives us 7 out of 8. The exact same answer we got earlier. And that's it for the first video. Hope you enjoyed it. Make sure you ask questions in the live session. See you soon. Bye.